completing the square. What does it mean to actually complete the square? Well, this is actually a form or way in which to solve quadratic equations. So we have to remember the format for a quadratic equation, ax squared plus or minus bx plus or minus c. When it's in the standard form, we're able to find a way to solve for this, to find out what it equals, where the answers are, where the graph crosses the x-axis. And the way we're going to do that is we're going to try and get a trinomial square out of this particular polynomial. And by doing that, the way we're going to do that is by taking half of the b, and then we're going to square it to get to the c. Now, let's just think about what a trinomial square looks like. It looks like this. Now, the reason why this is called a perfect square trinomial, because if we were to factor it, it would factor out two identical binomials. And we would be able just to say that this would be the factorization of that trinomial. So that's why this is called a trinomial square. That's what we want to get. We want it to be that way. Then if we can get it that way, we can use this idea of square and solve by square roots. So first, if we complete the square and then solve by square roots. And you'll see what I mean as we go through that. So let's first practice getting a trinomial square. So here I have a binomial x squared minus 8x, and I want to turn it into a perfect square trinomial. So I need to add a certain number here. Well, according to this step about taking half of the b here happens to be negative 8. If I take half of that, which is dividing by 2, that will get me negative 4. Now I'm going to square that, and I find out that that equals 16. So if I add 16 to this perfect square trinomial now, and if I were to factor it, it would factor out as x minus 4 squared. What's really kind of neat, if you like patterns, when you're working with square trinomials, is when you take half of this 8, this negative 8 in this case, what's really cool is that that answer of negative 4, just when you get the half, that's going to be in the binomial. And then once you square it, that's going to be how it's going to finish off. So we can kind of take some information and we can use it to our advantage. So let's see if we can figure that out again. X squared plus 12x. What would we add to this so that we would get a perfect trinomial square? And what would it be factored? Let's take it a step further. Okay, so we're going to have an x here. Now, we know that half of 12 is 2. Excuse me, half of 12 is 2 is 6. So what we're going to do is we're going to write here, we're going to write that this is going to be x plus 6 because that's going to go into that spot. Then if we square it, 6 times 6, that's going to give us 36. And that's going to be up there, so we're able to finish that trinomial square. So you can see the tie-ins that are there. Now, here's some important things to kind of notice. First of all, when we're squaring, we're always going to be adding. So instead of plus or minus c, when we're completing the square, it's always going to be adding c, because a negative times a negative is a positive. Now, the other really important thing is that this format only works when a equals 1. If your a does not equal 1, you're going to have to divide through to get it to be equal to 1 so that you can use this particular method of solving for quadratic equations. Okay, so let's take a look here. Now with equations, we're going to add that c to both sides because of the equal sign. So first of all, if we were to look at this part, x squared plus 8x, we know that half of 8 is 2. And if we take that, excuse me again, 8 divided by 2 is 4, and if I take that and square it, I'll get 16. So I need this to be a 16. Now there's two ways that I can do this. I think the easiest way for students to keep things straight is to get rid of the c that you have. And think about what is it that you want to add to both sides to get that perfect trinomial square. Well, according to this, because it's 16, we're going to add 16 to both sides. This we know automatically from this 4 right here that we're going to get x plus 4 squared. And negative 12 plus 16 is 4. So now we're at this point where we're going to take a square root of both sides. And the opposite of something squared, taking the square root of that, is just what's underneath the radical sign itself. The square root of 4 is either plus or minus 2. We're going to continue solving because that's what we're doing, trying to find out what a single x is. And we find out that x equals negative 4 plus or minus 2. Now let's break that apart. And that way we know that x can equal negative 4 plus 2, or x can equal negative 4 minus 2. Well, negative 4 plus 2 is negative 2, and negative 4 minus 2 is negative 6. So those are going to be our two answers. The parabola is going to cross either at negative 6 or at negative 2. Now we could prove this because this happens to be factorable. We could walk through it and prove it and get the factors. And if we had factored this out, this would have factored out to be x plus 6 times x plus 2. And if you remember you're solving by factoring, if you took each of these and set them equal to 0, you would have gotten these solutions as well. Now remember, factoring doesn't work all the time, so you need to know all 5 different methods. So this particular method comes in handy when a is equal to 1. That's probably the best time this works. So let's take a look at this again. X squared minus 6x plus 4. So we're going to start off by isolating the a and the b term. So then that way we get x squared minus 6x equals negative 4. And we're going to think about what numbers we're going to put in this spot so that we can get a perfect square trinomial. And that way we get that binomial square. So if we do that, we'd say, all right, we take negative 6 and divide it by 2. Well, negative 6 divided by 2 is negative 3. So we know then inside here in this parentheses, we're going to get x minus 3. Then we're going to take that negative 3 and we're going to square it. That works out to be 9. So what we'll do is add 9 to both sides. Negative 4 plus 9 is going to give us 5. So now that puts us at this place here. We take the square root of both sides, and we get x minus 3 equals plus or minus the square root of 5. Now I'm going to leave it as the square root of 5 because, you know, if you know anything about square roots of odd numbers, we're going to get something really kind of crazy for the square root of 5, since it is not a perfect square. So let me grab my handy dandy calculator here to show you. If I take the square root of 5, I'm going to get 2.23 in this long number going on and on. So this is the number I'm going to add or subtract from this other number that I get here. So I'm going to add 3 to both sides. I'm going to find out that x equals 3 plus or minus the square root of 5. It is perfectly acceptable to leave your answer in radical form just like this. Let's do one more problem again. 3x squared minus 12x plus 6. And at first you're going to want to get rid of this 6, but you're also going to notice that the a does not equal 1. So we got to fix that first. So let's divide everything by 3. Treating everything equally will give us x squared minus 4x plus 2 equals 0. Now we're going to isolate the a and the b by subtracting 2 from both sides, giving us x squared minus 4x on one side, and on the other side we get negative 2. We're going to take that b, which is negative 4, and we're going to divide it by 2, so we're going to get negative 2, which means that our binomial, perfect square binomials, 2 of them, they'll be x minus 2 squared. And if I take that negative 2 and square it, that's going to give me 4. So what I'll be doing is adding 4 to both sides. When I reduce the right side, negative 2 plus 4, I'm going to get the answer of 2. Again, I'm going to take the square root of both sides, and I get x minus 2 equals plus or minus the square root of 2. Then I'm going to add 2 to both sides, and x equals 2 plus or minus the square root of 2. And those are my two answers of where I'm going to see that parabola across the x-axis. So hopefully this helps in understanding how to solve by completing the square.